Okay, these are notes for section 10.2 parabolas. This is the start of conic sections. If you imagine a cone, like an ice cream cone, that has been a section sliced off of it, the two-dimensional section that you get for a certain slice is a parabola. So we have done parabolas in Algebra 1 and Algebra 2. We're just going to go a little bit differently about them in math analysis. I'm going to refer first to the diagrams I have down here. In a parabola can either open up, it can open down, it can open to the right, and it can open to the left. In Algebra 2, we did not cover the parabolas that open to the right or to the left because they're not functions. They're just relations. But in this section, we're going to talk about parabolas in both directions. So we're no longer talking about functions. In a parabola, the first thing we talk about is the vertex. The vertex is a point. In this case, it's this point here, this point here, this point here, and this point here. The parabola changes. In this case, the function is decreasing, and then it gets to this point, and it changes to increasing. So that place where it changes is the vertex. Increasing, decreasing. This is heading towards the left, it's heading towards the right. Heading towards the right, heading towards the left. All those points of change is where the vertex occurs. In a parabola that opens up and down, we call it a maximum or minimum value. So I'm going to say this is a point where the relation changes direction. So it's important to note that it's a point, and in the formula that we're going to use, I'll show you a little bit better in a minute, it's going to be the point HK. Okay, the focus, if I go back here, the focus is always inside the parabola. I'm going to zoom in just a little bit more so you can see this better. So this is a focus point here. This is a focus point here. See, it's in the interior of the parabola. Here, the focus point is here, and the focus point is there. The distance away from the vertex is a distance p. So this distance p from the vertex to the focus is how you find the point for the focus. So the focus is also a point inside the parabola. It's a distance p from the center, or from the vertex. There are formulas that go with this, and I don't memorize the formulas. I like to understand it. For students who like the formulas, I'll be glad to give you the formulas on any quiz or test. So here, the formula is H, comma, K plus P, because you're moving up. This one you're moving down, so the formula is going to be H, and then K plus P, but P is going to be a negative value. This is moving right, so it's going to be H plus P and then K. This one's moving left, but P is going to be a negative value, so it's going to be H plus P, comma, K. And that's one reason I don't memorize the formulas, is each formula could be different, and I just understand the concept a little bit better. The next thing we're going to look at is this directrix. So a directrix is a dashed line. It's not part of the parabola, but it's a distance p away from the vertex in the opposite direction that the vertex, or that the focus is. So in this formula, y is equal to k minus p. It's a horizontal line, so it's going to be y equals. Here's my directrix here. Still the formula is y equals k minus p. When the parabola opens to the right, or left, you're going to have a vertical line. So it's going to be x equals h minus p. X equals h minus p. So it's this dashed line, and it's a vertical line. So the directrix are all points to form a line. So equidistant from focus and directrix. So if I were to take a point on this parabola, the distance it is from the focus and the distance from the directrix are going to be the same. The last thing we talk about is this axis of symmetry. We don't use an axis of symmetry in math analysis as often. It just means that you're going to take this parabola and cut it in half. So if I were to cut this in half, it's going to be the same on the left-hand side as the right-hand side. And the axis of symmetry is just going to be x equals h. When the parabola is facing right or left, it's going to be y equals k. So the axis of symmetry passes through the focus and the vertex. Now I'll go through the examples, and I think it's easier to understand using the examples. Okay, here's my first example. And I'm going to take the zoom off a little bit. So I've got this equation, x minus 3 squared equals 12 y plus 2. This is the form that we tend to write it in for this textbook. That means the x term is squared. If the x term is squared, this is the same formulas that you would have used in Algebra 2. So the parabola either opens up or down. This 12 is a positive number, so it's going to open up. If 12 were a negative number, it would open down. So I've got the formula from the front page. I've got x minus h squared equals 4p y minus k. That tells me my h is 3 and my k is a negative 2. Since it's minus k and this is a positive 2, it's going to be a negative 2. So my vertex is going to be the point 3, negative 2. So I'm going to go up here and plot the point 3, negative 2. Then I know that this is going to open up, so I need the distance that it goes to the focus. My distance, 4p, is equal to 12. Since 4p equals 12, I know p is going to equal 3. So the distance I'm going to have to go up is going to be 3. So here's my focus here. The focus is a point, but I don't want to confuse it with my parabola. So I'm just going to mark it as an asterisk. So my focus is going to be the point 3, 1. Or h k plus p. My directrix goes in the opposite direction from the focus, and it's going to be a horizontal line. So if I go in the opposite direction, 1, 2, 3, there's my dashed line, and that equation is going to be y equals negative 5. So my formula would be y equals k minus p. My axis of symmetry goes right down the center, and I'm not going to draw it in there, but it's always the vertex, in this case the x value of the vertex, so it's going to be x equals 3. And the last thing I'd want you to do is to plot some points, and you can choose whatever points that you want. If I go back to this formula, I've got x minus 3 squared equals 12y plus 2. I'm going to choose a value for x and solve it for y. If I choose, let's say 0 for x. So I have, show the work down here, if I use the point 0. 0 minus 3 squared equals 12y plus 2. And I want to solve that for y. So negative 3 squared is 9. Then I'm going to divide by 12, so I have 9 twelfths equals y plus 2. If I'd subtract 2, so it'd be 2 minus 9 twelfths. So y is going to equal, or 9 twelfths minus 2. Negative 1 and 3 twelfths, or negative 1 and 1/4. So I would have the point 0, negative 1 and 1/4. 0, negative 1 and 1/4 is about there. I can reflect that, since I have this axis of symmetry, this distance away from the axis of symmetry. I'm just going to come over here and reflect it. I've gone 1, 2, 3 away, so I go 1, 2, 3 and mark it here. And then I can draw the curve. And it doesn't have to be exact. I do want to see that you've chosen some points. My next example is in the form y squared. So it'd be y minus k equals 4p x minus h. So my vertex is still hk. So h in this case is a negative 4. So this is y, x plus 4, h is negative 4, and k is 1. So I'm going to plot the point negative 4, 1. Now I know that this opens side to side, but with a negative 8, I know that it's going to open to the left. So I have to go left. So if 4p equals negative 8, I know p is equal to negative 2. I have to go left 2 to get to my focus. So this point here is going to be negative 6, 1. It's going to be h plus p k. My directrix goes in the opposite direction from my focus, so I know that I have to go right 2. So I'm going to go right 2, and there's my dashed line. It's going to be x equals negative 2 because it's a vertical line. So it's going to be x equals h plus p. Excuse me, h minus p. Let me make that correction. So negative 4 minus negative 2. And my axis of symmetry is this horizontal line that goes right through the vertex. So it's going to be y equals 1. And I know this is going to open right and left. I can pick any value I want and solve for the other value. I could pick an x value, and that's what most of you are used to doing. If I picked an x value, I'd put a number in for x and I would solve for y. The problem I have with that is I'd have to start taking square roots. So I'm just going to go ahead and pick for y and solve for x. If I put, let's go ahead and pick 5 for y. And the reason I'm choosing 5 for y is because I see 5 minus 1 is 4. 4 squared will be 16. And then when I take 16 divide by negative 8, I'm going to get an integer. So I don't have to deal with fractions if I don't want to. So I'm going to choose a 5 for y. And solve for x. So 5 minus 1 is 4. 4 squared is 16. 16 divided by negative 8 is going to give me negative 2. So I have negative 2 equals x plus 4. So I get x is equal to negative 6. So I'd have the point negative 6, 5. So negative 6, 1, 2, 3, 4, 5. And since I'm opening this way, I'm just going to reflect the point. Since there's distance 4, 1, 2, 3, 4 away from the focus here, I'm going to go 4 away from the focus there. And there's my parabola. And you can check these with a graphing calculator. Desmos does these very easily. The thing with a graphing calculator, if you use a TI-84, you have to be able to solve for y. There is a program that goes into TI-84 that not all our calculators have on it, that you could easily type this in it. It's not easy to check that way, but it's doable. The other thing that we have to be able to do is to go ahead and take something that's in standard form and put it into vertex form. And different books use different terminology. I think your textbook calls this general form. So we're going to start in this form, and we're going to rewrite it so it looks like these did up here. And we're going to use completing the square. The first couple times you do these, it might seem difficult, but it gets easier. So the first thing I want to do is I want to get the variables together that should be together. Let's zoom in one more time. So since I have an x squared term and an 8x, I want to keep those together, and I will move everything else to the other side of the equal sign. So I have x squared plus 8x equals 12y minus 28. I want to complete the square with the x squared plus 8x. I want to make this a perfect square trinomial. Well, if I take half of 8, which is 4, and I square it, I get 16. So I'm going to change this to x squared plus 8x plus 16. If I add 16 to the left-hand side, I have to add 16 to the right-hand side to balance my equation. This now factors as a perfect square. It will factor into x plus 4 quantity squared. And you can check this by taking this rate in x plus 4 twice and multiplying it out and see what happens. On this side, I can combine like terms. So negative 28 plus 16 is going to be a negative 12. So this is going to be equal 12y minus 12. I'm almost there. I want to get this in the vertex form with the h and k, and I can easily find all the information. And you'll notice I have a common denominator here, or I'm sorry, a greatest common factor, which is a 12. So I'm going to write x plus 4 squared equals 12y minus 1. This is the final form I was trying to get into. The reason for that is from here I can easily find the vertex, focus, directrix, and I can graph it. Not so easily when it's in the standard form up here. So vertex form makes it a lot easier. I'll give you one more example. Okay, I've got y squared plus 16x plus 6y minus 71 equals 0. My term that is squared is the y. So that means I want to get the y's together and move everything else to the other side of the equal sign. So I'm going to have y squared plus 6y equals negative 16x plus 71. This is the part that I want to complete the square. So half of 6 is 3, and when you square 3 you get 9. So I have y squared plus 6y plus 9 equals negative 16x plus 71 plus 9. I can factor this perfect square trinomial. This will factor into y plus 3 squared. Combine like terms over here, so I have negative 16x plus 80. Factor greatest common factor from this right-hand side, and I'll be done. So I have y plus 3 squared. I factor out a negative 16, and I'm left with x minus 5. And I would always just double check. Negative 16 times x is negative 16x. Negative 16 multiplied by negative 5 gives me my positive 80. So there I have it completed. And these just take practice. They're not difficult. In Algebra 2 you were supposed to have learned completing the square, and this is where it gets applied, is in math analysis.